when we talk of stars, it's natural that we first think of our sun. We imagine a gargantuan stellar object burning bright orange. But are all the stars the same? Are there stars of different sizes and colors? If yes, then what about the smaller stars? Can there be stars the size of planets? Is there a limit to how small stars can get? And what about the stars smaller than that? Are they still stars? Well, there are many questions that we can keep asking if we go down that rabbit hole. But for today, let's take a look at the brown dwarf stars, which are the stellar objects too small to be viable stars. Brown dwarf stars, like all other stars, are born in stellar nebulae. The stellar nebulae are giant clouds of dust and gas, held together by gravity. What starts the inception of stars is that sometimes in these clouds, gravity amasses the gases and dust together into balls. These balls, with their own gravity, start pulling in more and more matter, and keep growing in size. Soon, they reach the point where the density, gravity and heat of these balls are enough to ignite the fusion reaction of hydrogen in their core. This turns these spheres into burning balls of gases that we know as stars. However, it is the mass of these stars that determine their destiny. It determines what kind of stars would these burning balls of gases become, and what life path would they follow. When the mass of these balls is too low, they become brown dwarf stars. Brown dwarf stars are small stars that are too small to sustain their own light. They are incapable of continuing the fusion reaction for prolonged periods. At first, brown dwarf stars may seem like the anomalies of the stellar world, but in reality, they are more common than stars like our very own sun. Brown dwarf stars make up about a quarter of all the stars. And they are called brown dwarf stars because the temperature of these stars is extremely low, and they glow with a reddish-brown hue. Brown dwarf stars are about the size of Jupiter and possess a mass of 12 to 80 times that of Jupiter. We know that stars generate energy through the fusion reaction. When a new star is incubating and gaining mass, it reaches a certain critical point where it ignites this fusion reaction. Hydrogen atoms are fused to make helium and energy. At this point, the gravity, density and heat of the star create the perfect condition for the fusion reaction. The energy generated from the fusion reaction exerts an outwards force. This force is balanced with the inwards push by the star's gravity. This balance between the two forces is what allows the stars to survive and keep the fusion reaction going by maintaining the right conditions. Brown dwarf stars do not possess enough mass, and hence, gravity to maintain this balance. And so, because of weaker gravity, the brown dwarf stars slowly burn away their fuel and lose some of their mass. With time, the fusion reaction also stops, and these stars turn into cold giant spheres of gases, like our Jupiter, but much heavier. Well, that was all about this video. Do not forget to like, share and subscribe to our channel. Explified.